Hello everyone. For today's session, we will shall discuss about the alkyne. So for a short recapitulation of the things that you have learned from the previous discussion, so this is connected so doon sa una natin na diniscuss, which is about the alkene, and now we shall proceed to alkyne. So basically, the difference between these three organic compound is the type of bond that occurs in the molecule of the organic compound. Let's say for the alkane, we have single bond. For alkene, we have double bond, and for alkyne, of course, we have the triple bond. So alkynes are hydrocarbons that contain carbon carbon to carbon triple bonds. So the simplest form of alkyne is the acetylene, and the series of alkyne is referred as the acetylenes. So the alkynes have the general formula CnH2n-2 and have names ending with the suffix YNE. So the bond strength for the carbon-carbon triple bond is the strongest bond, carbon-carbon bond. So while the double bond carbon-carbon, so like the double bond carbon-carbon triple bond is highly reactive towards the region that the double bonds react with and towards some other. Okay, so for this module, you are expected to classify the alkynes according to the number and position of the triple bond in the molecule, give the systematic names to alkynes given their structure, draw the structure of the alkynes from their IUPAC names, correlate, predict, and explain physical properties of alkynes in terms of their structure, identify uses of some common alkynes, and realize the importance of industrial and biological functions of alkynes. So in terms of classification, again, the alkynes are classified according to the number of triple bonds present, or it can also be classified based on the positions of the triple bond in the molecule. According to the number of triple bonds, so we have three classifications. We have the alkynes, alkadines, and the alkatrines. So for the alkynes, we only have one triple bond present in the molecule, and then for alkadines, we have two triple bonds, and then for the alkatrines, we have three triple bonds. In terms of the positioning of the triple bonds, we have the terminal alkalines. So as you can see, we have triple bond at the terminal of the chain. For example, we have here CH, then triple bond, then CH, CH2, CH2, CH3. Okay, so that is a terminal alkynes. So the triple bond is located at the terminal. It's either in the right end or on the left end of the structure. And then we also have the internal alkynes. So from the word itself, internal alkynes, the triple bond is found within the chain. So it's not in the terminal. It's not at the end of either side or either end of the structure, but the triple bond is located within the chain of carbons. So in terms of nomenclature, the alkynes follows the general rule of the hydrocarbon nomenclature discussed in the alkanes and alkenes, and the difference is that instead of using the ANE and the ENE suffix, we will be using the YNE as suffix for alkynes. Okay, so just like in the alkanes and the alkenes, alkynes also follow the rule that we have to find first the longest chain of carbon in the structure. So for this example, we have eight carbons, eight carbons, and the considerations that we put in our mind is that we have to find the longest chain of carbon that contains the triple bond. And the second thing that we have to consider is how are we going to assign the carbon, the numbering or assigning numbers on the carbon. So sabi dito sa rule, we have to um, number the main chain beginning at the end nearer the triple bond so that the triple bond receive as low a number as possible. As low number as possible. Okay, so if we start here from the right, so the triple bond occurs in carbon 3 and carbon 4. But if we are going to use the other end of the structure, so the triple bond, carbon-carbon triple bond will occur in carbon 1, 2, 3, 4, 5, between 5 and 6. So meaning the most appropriate way of numbering the carbon is from right to left, because the carbon assignment, number assignment, would be lesser for the triple bond compared to if we are going to use the other side. Okay. So so in this example we have, so this shall be named as okay, so this one, so this is the octane or octine rather. So octine because we have here 1, 2, 3, 4, 5, 6, 7, 8. So octa, and then we we drop a, and then we substitute it with y and e. So that is why we have here the octine. And then we shall identify now our substituent. So the substituent have a branching on carbon 6. That is why we have here carbon 6, then locator, then the substituent is methyl. So the full name will be 6-methyl 3-octane. But if we are going to use the new system of naming organic compound, the locator of the triple bond must be put between the 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 then the indicators, between the oct and the octa, then 3-ine. Okay, so this shall be 6-methyl oct 3-ines. For rule number 2, compounds with more than one triple bond are called dienes, trienes, and so forth. So compounds containing both double bond and triple bond are called enines, or not inenes. So it shall be called enines because it contain the double bond. That is why yung representation of that is the en, and then for the triple bond we have the YNE. So it is called the enines. So numbering of the enines or enine starts from the end near the first multiple bond, whether double bond or triple bond. So when there is a choice of numbering, double bonds receive lower numbers than the triple bond. Okay, for example, we have here okay, Okay, for example, we have here the 1-peptine-6-ine. So we have here, so as mentioned um, in the rule, that if there are choices in numbering, double bonds receive lower numbers than the triple bond. So in this case, so we have here the occurrence of double bond appears in carbon 1 between carbon 1 and carbon 2. But if we are going to use the other end, so we have triple bond in carbon 1 and carbon 2. But pertaining as mentioned in the rule, the double bond shall receive the lower number than the triple bond. So thereafter we shall use the the signing of numbers in the carbon shall start from right to left. Okay, so we have now indicated here numbers for carbon from right to left. So after that, we shall now proceed to naming. So in the old naming system, or the classical naming system, so this shall be 1-peptine-6-ine. So 1-peptine, that is double bond is located in carbon 1 in the peptine. Peps, that represents 7 carbon, and then En, that is for double bond, and then 6 is the locator for the triple bond. So that is why we have here 6-ine. But if you're going to use the new system of naming organic compound, this shall be written as pep, that is the number of carbon, then 1 is the locator of the double bond, so we have 1 in 6-ine. So 6 is the locator for the triple bond. So again, this is now Hep 1 in 6-ine. For the second example that we have, so we have here carbon 1. If we are going to start from left to right, but if we are going to use the assignment of number to carbons from right to left, so the multiple bond occurs in carbon 2. So as mentioned in the ruling, numbers of an E9 chain starts from the end nearer the first multiple bonds. So in this case, the first multiple bond occurs if we are going to use this area in carbon 1, but if we are going to use in this area, that is carbon 2. So we would prefer assigning numbers from left to right. Okay, so next step is identifying the substituents. So this is methyl. So all in all, we have 4-methyl, 7 non-in, that is non is for 9, tapos the locator for the alkene is in carbon 7, that is 7, then 1-ine, that is also the locator for the triple bond that occurs in carbon 1. That is for the old or classical name. So if you are going to use the new system of naming organic compound, so again, the locator should be between the stem and then the suffix. Okay, so in this case we have 4-methyl, so the substituent is located in carbon 4, that is why we have here 4-methyl, non 7-in, non, then 7, 7, represents now the location of the double bond in carbon 7, and 1-ine meaning the triple bond is located in carbon 1. For rule number 3, as with the alkyl and alkynyl substituent derived from alkenes, respectively, the alkynyl groups are also possible. So for example, we have here the butyl, which belongs to alkane, and then the removal of one hydrogen in this structure causes the occurrence of the butyl, so it becomes now an alkyl group. So if so in the butyl, so if say for example there is occurrence of double bond, so it becomes now the alkenyl. So an alkenyl, in alkenyl it shall be written as 1-butynyl. So that means the double bond occurs in first carbon. And then if we are going to use the new system of naming the organic compounds, it shall be written as but1, that is in buta, so but1-enyl. Okay, so that is but1-enyl. And then if it occurs as an alkynyl group, so this will be known as the 1-butynyl. So in the new system, it is called but1-enyl. Alright, this time you try to name the following alkynes. Okay, for example, in letter A, again, this is a reminder to everyone that you have to apply other the IUPAC rules that were applicable in alkane and in the alkene. This was mentioned earlier that some of the rules that is applied in alkane and alkene are also applicable in alkyne. So for letter A, both and either way, the occurrence of triple bond is in carbon 4. So next consideration, suppose in our discussion, it was mentioned that we have to consider if the occurrence of the double bond. So unfortunately, there is no double bond in here. So we shall consider the branching of the substituents. So in the right side, if we are going to use the right side of the structure, it does not contain any substituent. Whereas in the right side, in the left side, it contains two substituents. So which one shall be much preferable way in which we are going to assign the numbers? For letter B rather, we have a structural formula, and then our consideration would be, are we going to use the closed cyclic system or the closed cyclic structure of carbon, or are we going to use this branch of carbon as our alkyl? Then for letter C, it's almost the same with letter A, but the consideration, the new this formula actually, we have here in the right side a branch out compared to letter A na walang branch out yung right side ng structure. So which one shall be used for the numbering of the carbon? For letter D, we have enines, the occurrence of both the double bond and the triple bond. So either way or either end, we have double bond in carbon 2, and then on the right side, if we are going to use the right side of the structure, the triple bond also occurs in carbon 2. So which end are we going to use for the number assignment of carbon? So we will be back on this slide before we end the discussion para magkaroon kayo ng time to solve for or to give um, the names of these alkynes. Alright, so this time you shall draw the structure of the following alkynes. For letter A, we have 3,3 dimethyl ine. For letter B, we have 3,4 dimethyl cyclodecyne. And then for letter C, we have 3-chloro 4,4 dimethyl non-1-in 6-ine. Preparation of alkynes. So the alkynes can be prepared by using either of the two processes. So it can be generating a carbon-carbon triple bond and increasing the size of the molecule that already contains triple bonds. So that means we can prepare alkynes from an existing alkane, and then we force the occurrence or the carbon to react and then form a triple bond between carbon and carbon. That's one. And then from an existing alkyne, we can extend the structure, and that's it. A new alkyne will be formed. Some examples of the um, alkynes that we have is the acetylene or the ethyne. This is known also as the ethyne. They are used in industry as starting material for the preparation of the acetaldehyde, acetic acid, vinyl chloride, and other chemical products. So um, yung PVC, yung polyvinyl chloride. So yung material is prepared from the acetylene or the ethyne. Then acetic acid present in our vinegar. So we have acetic acid in our vinegar. Then aside for this being used as fuel, it is also used in the oxyacetylene torch in cutting and welding metals. So yung ginagamit natin sa pag-welding. So yung fuel na ginagamit natin sa pag-welding is the ethine. Another is the triene or the trine from the sunflower. So they are used as plants' chemical defense against the nematode infestation in sunflowers. Another is the ethinylestradiol or ethinylestradiol and the norethindrone. They are components of the oral contraceptives that contain the carbon-carbon triple bonds. They act by artificially elevating the hormone levels in women and thereby preventing ovulation. So they are primarily used as contraceptives, oral contraceptives. So that would be all for the alkynes.